Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, let's solve a problem on flow through pipes in series condition. When there is a fluid flow is there and that is flowing through a number of pipes, let's solve a problem on this. So in our previous lecture, already we've discussed regarding the head loss or the rate of flow, how to identify when the number of pipes are connected in series connection. So let's solve this. The difference in water surface level in two tanks is 12 meter and which are connected by three pipes in series of lengths 300 meter, 150 meter, 200 meter, and the diameters are 0.3 meter, 0.2 meter and 0.4 meter respectively. Determine the rate of flow of water if the coefficient of frictions for pipes is 0.005, 0.0052 and 0.0042 respectively. Consider all minor losses and and neglect minor losses. So by considering all minor losses, we need to calculate the rate of flow. And the second one is by neglecting the minor losses, we need to calculate the rate of flow. So based on this question, we can draw a diagram for this. Okay, suppose this is the tank is there, because two tanks are the two surface levels of two tanks given. So let this is a tank is there, and this from this tank to again next connection is there. Suppose this is the pipe is there, and so here diameters are given different also. Pipe first one 0.3, again this is 0.2 and this is 0.4. so this is length also different, like this is 300 meter, this is 150 meter and next is 210 meter. So suppose this is the first pipe and this pipe diameter 0.3, let it is reduced, again it moved like this, again then from 0.2 to 0.4, again it was expanded. Yeah, then so from here or from here directly we can just from this pipe to we can take it to out, or here what is the discharge will be there. Now this is another tank, so another tank we have a surface level will be there, and here the surface level is there. So this one we can give just mark it some kind of liquid which is present here, and after coming out from these three pipes it will be there. So the difference between these two tanks, this is the label of this and this is the label of this another tank. So the difference between this two tank surface level is given, so that is nothing but h. So this is nothing but the height of this h, we can write equal to 12 meter. And this, see from this tank to this tank, how the fluid is flowing with three different pipes. Okay, three different pipes also we can mark it. This is pipe number 1, this is pipe number 2 and this is pipe number 3. And these three pipes we have all different lengths are there. So first one, the length is here, from here to here we can see how much is there, 300 meter. So this is 300 meter, that means L1, this one 300 meter, and from here to here this is L2, and from here to here this is L3. So L2 equal to how much? Now 150 meter, and this is L3 equal to 210 meter. So all are different lengths. Similarly, we have three different diameters also. This is diameter is 0.3 meter, and the next pipe diameter is 0.2 meter, and the next pipe is 0.4 diameter, 4 meter diameter. And also the coefficient of friction of for all pipes, so for this the coefficient of friction, that is F1, we can write this is 0.005, and this is F2 equal to 0.0052, and this is F3 equal to, here we can write F3 equal to 0.0048. So for all these data are given here, and we need to calculate the rate of flow of water. So that means we need to calculate the value of Q. The value of Q need to be calculated. So for that, what are the data given, we can write here one more time what we have written there. The same thing we can just write here in terms of all values. So L1 is given 300 meter. The next is L2 is given 150 meter, and next is given L3. L3 is given 210 meter. Okay, and the next is this is L1. Similarly, D1 is given. This is D1 is given 0.3 meter, and this is D2 0.2 meter, and this is D3 is nothing but 0.4 meter. Okay, now coefficient of friction also given. So this one we can write F1. F1 is 0.005, and this is F2. F2 equal to 0.0052, and next is F3. F3 equal to 0.0048. Okay, now here we need to consider all minor losses, and another one is neglect minor losses. So two things we need to calculate. That means Q need to be calculated by two methods. One is by considering all minor losses, another one is neglecting minor losses. Okay, so first if you remember the formula to find out this losses. Okay, so we know that our formula is, we can the relation was there, you know. So let me write down this formula. H equal to, we have the formula 0.5 V square. Here V1 we can give, or V square we can write, V square by 2G, plus we can write this is see, this is the entry point. So due to the entry in the pipe, what is the losses happened here? So that is minor losses coming under the minor losses. Then after that there is a fluid flow in this pipe. So this is major loss. So major loss in this pipe, so that can be considered like, you know, 4F1 L1 V1 square into 2D1G. Similarly, plus this is first one gone. Then second one, again it is in contraction. So in the contraction also same formula can be used, 0.5, and here it is, you know, V1 square by 2G. And here actually we can consider, if we were considering here V1, then this one we can consider V2. This one V2 we can consider here. Okay, then next is, again after coming inside here, second pipe, again we can write this is minor major loss will be there, that is 4F2 L2 V2 square by 2D2G. Then next is, after major loss, again it is expanded here. So that means expansion. There one different formula will be there. That is nothing but what is the velocity from here in the pipe and what is the velocity after expansion. That means V2 minus V3 square divided by 2G. This is nothing but very simple. What is the velocity in the pipe 2 and like before expansion, after expansion, what is the velocity? This square. So this is also minor loss. Then after that again, you know, there is a pipe flow is there. So this pipe flow is nothing but we can write the major losses. So this major loss also we can consider here, and this one we can write, this is similarly 4F3 L3 V3 square by 2D3G. And finally, when it is existing from this pipe, exit from the pipe. So exit from the pipe is nothing but we know that losses in the due to the exist, that is V3 square by, or V square by, actually the formula is V square by 2G. So here which velocity? Now 5, this velocity finally leaving. So that means V3 square by 2G. So this is the formula we have derived or we have found in the last video lecture when multiple number of pipes are connected in series connection. Okay, like this kind of conditions will be there. Now here if you see everywhere some velocities are there, V1 like V1 V2 V2 V3, 3 velocities are there, but here velocity values are not given. So let consider V1 is flowing in the value, pipe 1, V2 is flowing pipe 2, V3 is flowing pipe 3. Okay, so here just what we'll do, as we know that from the continuity equation we can write A1 V1 equal to, we can write A2 V2 and equal to, we can write A3 V3. So from this equation we can also write, like for all these pipes it is applicable. So from that we can write what, now first equation if you take first these two equation if you consider, then we can write V2 equal to A1 V1 by A2. Okay, now again if I write A1 value and A2 value, that means pi by 4 d1 square, and similarly in denominator again pi by 4, this is d2 square, and here in this things we can write this is V3, pi by 4 pi by 3 will be cancelled. So here what we can write d1 square by d1 square by d2 square. So d1 square by d2 square, again we can write the diameter. So that is diameter d1 given how much? So this is 0.3 by d2 is given 0.2. So 0.3 by 0.2 whole square into V3. Okay, so this one we can write, sorry, here V2 in terms of okay, these two things V1 and V2 is supposed to be taken. Here V2 actually A1 okay, no, V2 we have written now, yeah, A1 V1 by A2. Now A1 V1, so this is A1 V1, okay, corrected. This is A2, correct. Now this will be V1, not V3. This is V1. Actually our target is we'll convert all these velocities in one single velocity. So because 3 velocity required, single velocity values are not given. So by considering this continuity equation, we can just convert all this velocity into single term, single velocity. So that's why what I'm writing here, we just can 3 by 2, and here we can write whole square will be 1.5, 15 square 225. So 225 into V1. Okay, this is one term. Now similarly again if I write in terms of V3 and A1, like this A3 V3 with respect to A1 V1. Now similarly I can write here V3 equal to, we can write what, A1 V1 by A3. So similarly again by pi by 4 d1 square by pi by 4 d3 square. So finally cancelling this will, what will get, now d1 square by, will get d1 square by d3 square into V1. Okay, now see in terms of V1 I am converting all the things. Now d1 equal to again 0.3, so here will get 0.3 divided by 0.4 whole square, and this is V1. So 0.3 by 4, or if you take 3 by 4, then 30 by 4, that means 0.75. Again it will be like 3 by 4 square, 0.5625. So this is 0.5625 V1. So see, now V3 also I have written in terms of V1, and V2 also I have written in terms of V1. V1 already there, V1. Okay. So now what we'll do, we'll just put all these values in this equation. See in this equation, if I tell you, this is minor loss, and minor loss, and this is major loss. Major loss will give in different color. This is major loss, this is major loss, and this is major loss. Now what first point it is given, consider all minor losses. So we have considered all minor losses. Second point is given, neglect minor losses. So let's put all this value in this equation, and finally what we can write, h equal to, what we can write, h equal to 0.5 P1 square by 2g plus, again 4f value is there, so 4 into f1 value 0.005, L1 value 300, 300 into v1 square. So v1 square is nothing but same v is there. So v1 square by 2g. Then next is again 0.5 v2 square. So 0.5 v2 square place we can write the v2 value. So this is 2 d1g. So d1 value how much is there? You can write 0. I hope 3 is there. 0.3. Yeah. 0.005, 0052, 0048. Okay. Now this is minor loss, major loss, then minor again v2. So v2 we can write in terms of v1. So that is nothing but 2.25. 2.25. This is v1 square. So you can write this v2 equal to in terms of v1, this one the term. Now again we can write here 2g plus major loss again. This is minor, again major will come. Now major again 4 f1 f2. F2 is 0.0048. I hope 48 or 52. 52 into length is given there, second length 150. So 150 length f, then v2 there v3 square. So v3 place we can write this is how much we can write here. Yeah, here we can write some value will be there. So that one 150 and v3 value. V3 value how much is there? Now this is v3 value. Okay, so v3 what we got here in terms of 0.0525. So here we'll get 0.05056 0.56. 0 is not there. 0.5625. So this much v1 square and divided by 2g into d2. d2 is nothing but 0.2. And next again this is major loss completed. Again minor loss will come, like what is the expansion. So there we can write what is the v2 minus v3 plus we can write here 2.25 v1 minus 0.5625 v1 whole square divided by 2g. Again plus will be there. Again major loss will come. So that is 4 f1. So here 0.0048 into 210 into v3 square. V3 square here what we can take? V3 already this one. Now this is v1, v2 I hope. v2 what we got? 2.25, correct. v3 this one 0.5625. Then this one we have written v1. Then here v2 supposed to be written, I hope. This is v2, correct? This is v2, that means 2.25 v1, and here it is v3 will come. Okay, now v3 here it will be like 0.5625 v1 square and divided by 3g. So 2g into d3 equal to 0.4. This is major loss. And finally, what is the exist loss is there? That is v3 by 2g. So v3 by 2 is nothing but 0.56. This is 25 whole square by 2 into g. Now what I'll do, this is h equal to this equation. So what I'll do, I'll just write h value how much is there. H value is, this is given h value 12 meter, this height. So h equal to data given 12 is there. So let's write it. This is in the data given. This is 12 meter. Okay. Now here I'll write 12 and all these values what is there. I'll take the v1 square by 2g, let common. v1 square by 2g, let take it common. Let's put it in a bracket. So what will be there here? 0 v1 square by 2g gone means first point you can see only 0.5 will be there. 0.5. Next remaining value will be there. So that will solve it here. So let's solve this one. Yeah, 4 into 0.005 into 300 divide, yeah, okay, 300 total came 6, okay, divided by 0.3, I hope. So this is 20. So this is 20. Again similarly v square by 2g gone, so remaining what will be there? v1 square by 2g gone, so that will be 2.25. so 2.25 square into 0.5, so 10.125. No, it should be, I think half of this means reduced. It should be reduced actually. Okay, square I have done, no, half. So again let's do it. So 2.25 square multiply 0.5, yeah, 2.53. so this is 2.53. Third one gone. Next is, again if you see here, next value is v1 square by 2g gone, so remaining how many are there? So that is 4 into 0.0052 and multiply of 150 into 2.25, again 2.25 multiply it, equal to this much and divided by 0.2, 78.975. Anyway, what are the values came? We can write the same thing, 78.975. Again next is this one. So this one again v1 square by 2g we have taken common. So v1 square by 2g, if it's gone, then remaining how much will be there? This value minus this one square. So that means 2.25 minus 0.5625, this much square, 2.838. So you can write the same thing, 2.838. Yeah, so you can write just 2.84. Okay, now again my major loss is there, this one. So again multiply this. So 4 into 0.0048 into 210 into 0.5625 into 0.5625. How much is there? Divided by 0.4, 3.189. So write down the same value, 3.189 plus, again last value is there. So last value is nothing but 0.5625 square, 0.316, 0.316 bracket close. Now if you see at this point, this is our minor loss. Okay, this is minor loss, again this is minor loss, and this is also minor loss. These all values are minor loss which came from here, and remaining values are what? Remaining value, this is major, major and major loss. Anyway, by considering all minor loss and major loss, we need to find out what is the rate of flow. So now what I'll do here, I'll just add all the things and I'll take this file to here. That means what I want to say, I want to find out the V1 value. So any one velocity if you identify, then we can calculate the rate of flow discharge. So rate of flow discharge, what I'll do, just I'll write V1 square equal to 12 into 2 into 9.81 divided by all this value what we got here. Correct. So let add all the things. So this plus 316 plus 3.189 plus 2.84 plus 78.975 plus 2.53 plus 2.53 plus 20. 20 plus 0.5, 108.35. Anyway, 108.35. Okay, so here what we can calculate, we just can write v1 equal to root over of this value. So that is, again we can calculate the same one, like 12 multiply 2, again multiply 9.81, 235 point, here 235.44 divided by 108.35. So finally we can get the value of velocity equal to just this divided by 108.35. This is root over of this 1.474. So 1.474, this much meter per second. Okay, now this is the velocity, but our target is we need to find out the rate of flow. If you see the q, we need to calculate. Okay, so now we can write, we know that q equal to a1 v1. So area already given, pi by 4 d square, you can calculate pi by 4, 0.3 square into v1 value we got 1.475. Now if you calculate this, we can find out, let this is the value is there, multiply 0.3 into 0.3 into pi equal to divided by 4, 0.104, 0.104 this much meter cube per second. Anyway, what is the value we will get, that much we can write, no issue, 0.104 meter cube per second. If you, this one we can write in terms of liter, then 100 liter will come, like 100.4 and some value that is liter per second. So this is about the rate of flow, or you can say the discharge through the pipe. This is one answer. Now second answer is what given? Second answer is given, second question is given, neglect the minor losses. So second things we can write, by neglecting the minor losses, directly I'll take the value from the previous one. There means that h equal to, what if there h equal to, this portion will be not there, this part, minor losses part will be not there, so only major losses will be there. Okay, neglecting the minor losses. So by neglecting the minor losses, what will get, here I can write h equal to how much, direct, I'm writing directly the value 12, and here v square by 2g I can take common here. So same thing what I done there, I can write here v square by 2g, and directly value I'll write here. What are the value I got previously? Same, like minor loss value. Yes, so major loss value 20 plus 7.8, 20 plus 78.975, and one more is there, that will be how much, 3.8 something, 3.189, 3.189. I hope the bracket is closed now. Now what we'll do, same method, just we'll take this v1 one side, and this is 12 into 2 into g, and divided by this total value root over. Okay, just to calculate this value, how much is there, 20 plus 78.975 plus 3.189, 102.164, 102.6164. Okay, now in the numerator also, let's calculate the value here. So this is 12 into 2 into 9.81. How much is that? 235.44. That previously also we have calculated the same value got. So 230.44 root over of this, and divided by 102.164. Now finally let me write v1 equal to this value divided by 102.164 2.3 root over of this 1.518. So 1.518 meter per second. Compared to previous, here we got, I think, slight more velocity value. Now see, previously we got 1.475. Now we got 1.518. So finally, again, we need to find out the discharge or the rate of flow Q. Again, we can write A1 V1, and here we can write pi by 4. Again, D1 square into V1. V1 is 1.518. So just to multiply this into pi into 0.3 into 0.3. This divided by 4. 0.107. So Q equal to what we got? 0.107. This is meter cube per second. Again, this one, if you want to write in terms of liter, then what will get? 107 liter per second. Okay, so this is the final answer for when we won't consider the minor loss. Now, how much difference we got here? If you see, this is the rate of flow 107 liter per second, and previously 104 liter per second. Thus, there is a slight difference between the rate of flow when you consider the minor loss and when you neglect the minor losses. So I hope you understand this problem, how to solve it. Still, if you are having doubt and query regarding this, you can give a comment on the comment box. Thank you all.